Hey everyone, welcome to today's developer workshop for the Tezos and CoinList Hackathon. So I think we're going to get started. Today we have Matej from Stove Labs speaking to us about TZIP12, or also known as FA2. And he's going to go through some demos and then kind of walk through what he's been building with his team at Stove Labs. And finally, feel free to toss any questions into the Q&A section in the Zoom, and Matej will answer the questions as we go. And yeah, thanks for coming today, Matej. Feel free to take over.
Thanks, Spencer, for the introduction. So I'll just do a quick intro on myself again. My name is Matej Shima. I'm the founder and a software engineer at a company called Stove Labs. What we do is we focus on building tools for blockchains, especially for Tezos. So my background is front-end engineering, and I've turned to the dark side of blockchain in about 1.5 years ago. And today I would like to show you a lightning preview or a demo of some things that we've been working on for the past weeks at Stove Labs. Some of them are a bit younger, some of them are a bit older, but it doesn't matter at the moment. So we will be talking about a token standard that goes under one or two names. So you may know it as TZIP12 or FA2. So a brief history of the standard is basically that in September last year, we started working on a NFT-based Tezos game called the Tezos Hunt. And as part of the effort, we've also started to define a token standard. So this has turned into a broader community effort during autumn or winter. So that's how TZIP12 came to be. TZIP12 is currently being maintained or proposed by TQ, so the Tocqueville Group. And we at Stove Labs are building a reference implementation of the standard and some of the tools around it. So today I'm going to show you my toolkit for contract development and how I use the toolkit to build the reference implementation of the TZIP12 standard. And on top of that, I'll show you an SDK, a TypeScript library that we're working on that can be used to interact with either our reference implementation or multiple other reference implementations of the same standard. So the first thing I want to talk about is a thing we call the starter kit. So let me just close this and show you the starter kit. Yeah, here we go. So a starter kit is a repository that we've put together at Stove Labs, which we use for all of our smart contract development on Tezos. Essentially, it's a truffle project with some sparkles on top. So it contains a sandbox integration and an index integration as well. And it has some couple of nice niche features too. So this is what we use for all of our smart contract development. It's open source, so you're free to use or welcome to use as well. Welcome to use it as well. If you have any issues about or questions about the starter kit itself, we'll be happy to help you out during the workshop or during the hackathon itself. So this is what we use for the TZIP12 standard implementation as well. Now let's take a look at the TZIP12 repo itself. Let me just pull it up here. So as you can see, the project structure is exactly the same because it's essentially based on the starter kit. So you have a nice readme just explaining to you how you can start a project yourself if you need to, and the link to the documentation. The documentation we will be releasing in the coming days. So please stay tuned and follow our Twitter to see the latest news. Yeah, so what I want to show you is how the TZIP12 token standard implementation is benchmarked how it can be deployed, and how it is tested. And then I'll show you a quick demo of how you can use the SDK to interact with one of the implementation flavors from JavaScript or TypeScript. So, so moving on, we are now looking at what we call the Stolop's Kitchen. This is a project we've been working on for the past month. It contains essentially all of our knowledge combined for the past years, like combined blockchain and development experience. And it's also home for the reference implementation of the TC12 token standard. So you can see a bunch of cells here, a bunch of text that we don't care about at the moment. You can also see the implementation status, so which entry points are implemented, and then how much it costs to run the contract. So you can see an overview here, the total cost, the gas limits, and the storage limits that have been used for deploying the contract. So this is very, very important to understand. If you're planning to build a product on top of TC12, you need to understand the costs behind the contract and how much essentially you will end up paying for deploying this once it goes live. So this part of the documentation should give you an overview of how much things cost within the TC12 implementation that we did. And then moving on, we have the SDK that I've mentioned previously. So here we have an example of how it can be used. So it's a TypeScript library, so you first have to import it. So you install it from, currently not from NPM, but from the Git repository. But once the release is out there, you can use it from NPM as well. So a couple of things that we have to do first. So first of all, we configure Taquito, which is a TypeScript library for interacting with the RPC. We configure it to use the local node that we have running. We configure a signer, etc. Things that we don't care about at the moment too much. And then for the SDK itself, so the SDK architecture is done in a way that you can use the single SDK library with multiple different implementations of the TC12 standard. So this might sound a little contradictory, but in fact, the standard itself is standardizing only the entry points or the functions that you can call on the smart contract, and it does not standardize the storage representation of the smart contract. This is a intentional decision on the side of the contract design, and what you can achieve by basically leaving the implementation details of the storage loose is that you can have different implementations optimized for different use cases. So in our case, right now at the moment, we provide two different implementations. So we have an NFT implementation and then an NFT implementation with a different storage structure. So we have two NFT implementations. One uses a storage structure called Big Map, and the second one uses just a simple map. And if you scroll up here, you should be able to see, for example, the cost differences for each of those implementations. So using a big map is nearly 3 times more expensive than using a regular map just for origination. Of course, this will change as soon as you start profiling, for example, the transfer. There, the big map will have an advantage over the simple map in terms of the costs. So that's something that's going to be added into the benchmarks in the coming days. So back to the SDK. So you have the adapter architecture, and each of the adapters exists for each of the implementations. For the NFT implementations, we currently have just one adapter, but we will need 2 for each of the different storages. And what the adapter does, it just parses a different storage of the contract. But the entry point interaction, the data model, etc., that stays the same with the SDK. So if you are, for example, a wallet developer, or you are building I don't know, a ticketing system or a reward system or even a game using NFT tokens, you can use the SDK on your front end, for example, or anything that is TypeScript or JavaScript based to reduce any overhead related to TC12. So if there's a change in the standard, if there's an amendment to the standard, you don't have to worry. You just use the same SDK and we take care of the rest. So that's the point of the SDK. Here we can see how it can be used to originate and transfer some tokens. So the first thing that we need to do is create a new instance of the SDK and pick an appropriate adapter. So that's what we do here. We pick the NFT contract adapter and we configure it to use a certain indexer. So as part of the starter kit, you also have an indexer that you can run locally on your local sandbox. And this indexer allows you to access stuff that is not available through the RPC directly, so on the node directly. This is very important because the SDK allows you to, for example, get all the tokens from the contract. And this is something that you would not be able to do using the plain RPC. So the plain RPC would not give you all the keys that would exist in a big map, which is a problem if you're trying to build a UI, right? So as part of the adapter, we also use the indexer that is also publicly available for the public networks, but we use the local instance in this case. So you configure the adapter, you configure the indexer for the adapter, you pass in your Taquito instance that you are going to use, that you have configured above, right? And you can proceed to actually originating or deploying your own contract. So if you were in a wallet, you would have, I don't know, a certain functionality to deploy or create new tokens. So this is the piece of code that you would use. So you would call the SDK to originate a new contract, and you would pass it an array of tokens that you want to store in the contract. And it's quite straightforward. So the data model goes, you have an NFT token that you want to start with an ID, which is 0, and you want to set an owner for the NFT token. So we now have 2 tokens, one with ID 0, one with ID 1, and both of them are owned by Alice. And this is how we originate our token. So what the SDK gives us back is an origination operation, and we have to wait for the operation to be included in the chain. So we do that by waiting for the confirmation. Usually a good practice is to wait for more than one confirmation in case you have competing chains or whatever else. But for the sake of this example, we just have one confirmation. Once the new contract is deployed, we reinitialize the SDK using the contract address that we have just deployed above. So that's what we do on this line. And then we want to transfer one of the tokens that Alice owns. So we want to transfer the token with the ID of 0 to Bob. So this is how you can do a transfer from the SDK. First of all, you have to retrieve the token. So retrieve the token with the ID 0, and then you transfer. This is actually a mistake. There should be amount 1 because you should be transferring 1 token, not 0. But we'll talk about it later. And you're sending the token from Alice to Bob. And then again, you wait for the confirmation for that operation. The reason why this example will work with amount 0 is because the way the underlying NFT TC12 implementation is done, and it's done in a way, so if you have an NFT token, the amount for that token will always be 1. So there's only going to be 1 token in existence with that given IP. So the implementation doesn't even check the amount that you're trying to transfer, because the logic that it uses to determine if you have a sufficient balance of the token is by checking if you are the owner of the token, because there can be only 1 owner per 1 token ID because it's a non-fungible token. So that's why setting an amount to 0 works here, but it doesn't really make sense in terms of the SDK, right? It should be 1. And the last and the final step is to check the balance, or basically to check if Alice still owns the token with the ID 0, and the result will be 0 because Alice does not own it anymore. So that's more or less the round trip of how the SDK operates. And I'm going to show you, I'm going to run the code snippet myself, and I'm going to show you the results in the indexer, and then check the cost table compared to what the indexer is showing. So let me pull up the project first. Just a moment. All right. So I've got the project here. Okay, here we go. So close this, close this. All right. I hope you can see the screen. Let me start again. I don't know if you can see it or not. Screen sharing. Yeah. All right, you should be able to see it now. All right, so I'm actually not sure if you saw the screen up until now. If you could let me know in the chat, that would be nice. Okay, so I guess you saw the screen. Okay, all right. So this is the same snippet as we've shown in the, as you've seen on the website. And now I'm going to run it. And then I'm going to show you how it looks like in the indexer or in the Blog Explorer. But before we run it, we need to save the contract address somewhere so we know what to look for in the indexer. So let's do that first. Contract address. Contract address. Right. Let's just log that so we know what to look for. Okay, so this is the address that we should be looking for once the code finishes running. Right. So now let's take a look at the indexer, which we should have running locally. Let's take a look here. Right. So localhost 8000. And we search for the contract address that we have deployed using the SDK. And we see that it's a contract that is what it's supposed to be. And we see that it has been originated, and then we send one transfer to it, all of that done using the SDK. We see the initial data structure, so we know that there are 2 tokens, both owned by Alice. And then after the transfer happens, one of the tokens, the token 0, is transferred to a different address, which is shown here. So this is Alice, and afterwards the ownership is transferred to Bob. So another thing that we could do is compare the costs that we had here, but then I'm thinking real quick. So we only have 2 tokens here and here, and in the benchmarks we have many more tokens. We have, yeah, in the hundreds, right? So, but anyways, you should be able to use the SDK to deploy a similar amount of tokens and see if the benchmark is actually correct or not. The benchmark has been done on a sandbox network that should have the same properties as the cartridge network, but there could be some mistakes. I don't know. We haven't tested it that much yet. So That would be it for the quick demo. If you have any questions about TZIP 12, the SDK or the kitchen or about store labs or about anything else, I'd be happy to answer it. And if not, then the last thing I would like to say is that if you choose to build any product using TZIP 12 during the CoinList Hackathon, I'd be very happy to help you add any additional features to the TZIP 12 implementations that we have, or help you with your smart contract development, or any other Tezos related help that you might need. So that will be it from my side.
Awesome. Thank you for your time, Matej. Does anyone have any questions here? Cool. Okay.
Yeah, just
If no
maybe
questions,
to,
then
yeah,
as usual, this will be uploaded to YouTube. I will
sure.
get this up by the end of the day today. And yeah, thanks again for your time. And if any of you
Yeah,
have any questions for Matej, feel free to toss it into the Discord. And
yeah, sure. I mean, you can reach out to me on Telegram if you want, or Twitter, doesn't matter, or even Discord, right? I'd be happy to help you.
awesome. Thanks a lot, guys. Have a good one.
Thanks. Bye.